Good morning, one and all physics students, to another edition of Finzics. It's Mr. Finn with you again on Tuesday. Hope you guys are doing great today. Um, we'll have a little more clarity on what the educational status is going forward. But right now, we're just going to continue with our study of circuits. I'm going to handle some of those grade questions as soon as I know a little bit more from our district administration. All right, one other note. This week's Google form on Thursday will be on statics and fields. So this is electrostatics and electric fields, which is the information that we were doing in class before the break. So that would have been tested on March 17th. So I know it's a little bit of a time difference there, but I have a Google form ready for you. And we're going to complete that between 3 p.m. and 6 p.m. on Thursday of this week. So that'll be your Google form for the week, guys. And if you can just complete that on statics and fields, I'll make sure to get some stuff going there. Okay? All right. Secondly, got a question into the email bag today, or the other day, about voltage drops. So some students are really not too familiar with the concept of applied voltage or voltage drop. Fair enough. It's kind of a complicated example or subject, so we're going to handle that a little bit more today and get you guys squared away. So I'm going to give you an example, graphical, and then I'll take you through another example with the circuit that we had on drawing the board yesterday. Okay, guys, so let's take a look at applied voltage or voltage drop in a series from the circuit that we had Monday. Okay, guys, one good way of looking at voltage drop or applied voltage is it's the amount of voltage that takes you around the circuit. That's the total. So remember yesterday's circuit, we had 3 bulbs, a 1 ohm bulb, a 2 ohm bulb, and a 3 ohm bulb. Well, there were 2 amps of current going through it because it had a 12 volt supply. Refer to yesterday's video and notes if you don't remember that. Welcome back. Okay, so we have 12 volts to begin our circuit. That means at the front of the battery, there's 12 volts of electric potential. Now, if we go all the way to the back of the battery, all the way around the loop, we know the back, relative to the front, has to have an electric potential of 0 volts. So there's going to be 12 volts of push through this circuit. The battery is what pushes the charge along, or the section of batteries. So that 12 volt supply, when it hits bulb 1, is going to lose some of that push because that push has to expire to get the charge across the resistor of bulb 1. Now we could actually touch our multimeter on both ends to measure that voltage. But if we go from 12 volts to 10 volts when we cross bulb number 1, there's a drop of 2 volts across that resistor. Now, the current continues and the voltage is going to be the same from the end of bulb 1 until it hits bulb 2. So anywhere along that line, there'll be no voltage drop. It'll be the same voltage. But once it hits bulb 2, then a new voltage drop will be created. A voltage drop which is the same as 2 amps times the 2 ohm resistor, or a 4 volt drop. Therefore, our total voltage goes from 10 volts down to 6 volts. Now you may be asking yourself, where does that push go? That push is required to get the charge through the resistor. Now, how much push is left? It's just whatever's left after the 1 and the 2 ohm bulbs expire, or we get past those bulbs. So once we get past bulb 2, I only have 6 volts left, and that's going to drop me down to 0. So at the front of bulb 3, I have 6 volts of electric potential. At the back of bulb 3, I have 0 potential. And that's the same as the back of the battery. Now let me throw this up here in a circuit so you guys can see. But I think this graph is helpful because the applied voltage term can also be seen as a voltage drop, graphically dropping 2 volts and then 4 volts and finally 6 volts to get us down to 0. Now, if we didn't have one of those bulbs, one of those drops would go away and the new graph would be seen with just the 2 remaining bulbs. That's something I can also show you. But let's take a look at this graph in terms of the circuit itself that we drew from yesterday. Okay guys, welcome back. Now, I drew the same circuit as the one we had yesterday, but I want to talk about it a little bit differently. Yes, we know a current's going to run through the whole circuit, but on this particular circuit diagram, I've put some letters to indicate random spots that we might be able to attach our voltmeter in order to be able to measure voltage. Point A, which is the same as the front of the battery, because nothing occurs in the circuit between front of the battery and point A. Point B is after the resistor. Now, conceptually, I drew point C in here, which is right at the front of bulb number 2. But if you can see, there's nothing in between points B and C on the diagram. There's no resistors, no capacitors, no other electronic equipment whatsoever other than a wire. Theoretically, B and C should be at the same voltage because there's been nothing to drop it. So electrically, those are the same points. Points D and E are also electrically the same because there's nothing in between them. But points C and D are different electrically. Why? Because there's something in between points C and D. Resistor 2. How much resistor 2 value? 2 ohms. And remember, we had 2 amps going through the 2 ohms because that was the current for the entire circuit. Therefore, using Ohm's law, V equals IR. The 2 amps of current through resistor 2 times the 2 ohms gave us 4 volts. And if you'll remember, on our diagram, we dropped 4 volts across resistor 2, meaning from point C to point D, we lost 4 volts of push getting across that resistor. Now we can do this by taking our voltmeter and pressing the 2 leads on either side of that bulb, and my reading should give me 4 volts. Okay guys, so to sum up today, applied voltage or a voltage drop is basically just the amount of push that applies to that device. So resistor 1's voltage drop, the total voltage will be applied in proportion to just that bulb. So voltage drop, applied voltages, similar terms, they're really interchangeable, and hopefully the graph helped today. Tomorrow I'll get you into some lab setups for that, but let me just show you real quick. The 2 parts of the bulb are easy. You can see this bulb right here has 2 clips on it, and those clips represent one side of the bulb or the other. In fact, this clip is attached to the side of the bulb, and the other clip is attached to the bottom of the bulb, right there. So, if you touch your device, your multimeter, got my multimeter right here, if I set that to measure voltage, and I touch those leads on either side of the bulb, like so, that's a way to measure voltage. So that voltage across that bulb would be measured by this meter. So I have the meter hooked up. I'll show you that tomorrow in another lab setup, and I think I said that, I tested that for you guys last week, or week before break. But just to give you guys a little heads up on that. Remember, Thursdays are Google Form. I'll try to make that available about 3 p.m. on Thursday for statics and fields. I'll do a little review on Thursday about that. But hopefully you guys can get a little bit of work with circuits, series circuits. Remember, page 552, 553 has some of those rules on there too. So good luck, guys. Take care, and we'll see each other tomorrow.